The Daimler Start gas engine is one of the pioneering developments in the history of internal combustion technology. Designed by Gottlieb Daimler in the late 19th century, this stationary engine marked a major step toward modern motorized transportation and industrial power systems. The engine was compact, efficient, and versatile, built primarily for stationary use, such as powering machinery, pumps, and small workshops, before similar designs were later adapted for vehicles. Unlike the large, heavy steam engines of the time, the Daimler gas engine was light and could start quickly, thanks to its innovative high-speed design. It operated on coal gas and featured a vertical cylinder, an open crankcase, and a simple yet reliable ignition system. This practical design made it ideal for continuous industrial use and demonstrated the advantages of internal combustion over steam power. The Daimler Start gas engine is widely regarded as a cornerstone in the evolution of modern engines. It not only showcased Daimler's engineering ingenuity but also laid the foundation for future gasoline and diesel engines. Today, restored examples of this engine, such as those preserved by Gunter Werner in Luden, serve as valuable artifacts, illustrating the technological breakthroughs that fueled the industrial age. The Cromhout HS2 stationary diesel engine is a classic example of mid-20th century European engineering excellence. Built by the Dutch company Cromhout MotorenFabriek in Amsterdam, the HS2 model was part of the firm's renowned series of heavy-duty diesel engines used in both industrial and marine applications. As a two-cylinder, four-stroke stationary engine, the HS2 was designed for reliability, durability, and efficient fuel consumption, making it ideal for continuous operation in workshops, power stations, and small factories. The engine's robust cast-iron construction and precise mechanical components reflect Cromhout's reputation for producing engines capable of running for thousands of hours with minimal maintenance. Typically water-cooled and started by hand or compressed air, the HS2 delivered smooth, consistent power output suitable for driving generators, pumps, or other machinery. Beyond its functional qualities, the Cromhout HS2 represents a significant era in industrial history, when mechanical simplicity and craftsmanship were valued as much as performance. Today, preserved examples of this engine can often be found in museums and private collections, where they continue to demonstrate the enduring legacy of Dutch engineering and the evolution of diesel power technology in the 20th century. The Cromhout KS2 stationary diesel engine is a classic example of early 20th century Dutch engineering excellence. Manufactured by Cromhout MotorenFabriek in the Netherlands, the KS2 was widely used for industrial, agricultural, and marine applications. This two-cylinder diesel engine was known for its reliability, durability, and fuel efficiency, making it a preferred choice for powering pumps, generators, and small vessels. The engine featured a robust cast-iron construction, open flywheels, and a slow-running design that allowed smooth and steady operation even under heavy loads. The KS2 reflected the mechanical craftsmanship of its era, emphasizing simplicity and ease of maintenance. Many examples have survived and are preserved by enthusiasts in museums, often restored to working condition to demonstrate the impressive engineering of early diesel technology. Today, the Cromhout KS2 stands as a symbol of the transition from steam to modern internal combustion engines. The Atlas Stockholm Air Blast Injection single-acting diesel stationary engine is an early example of industrial diesel technology developed in Sweden by Atlas in Stockholm during the early 20th century. Designed for stationary applications, this engine was primarily used to power workshops, pumps, generators, and other fixed machinery. It operates on the single-acting principle, where combustion occurs on only one side of the piston, simplifying construction and maintenance. The air blast injection system, an early diesel fuel delivery method, uses compressed air to atomize and inject fuel into the combustion chamber, ensuring efficient combustion and steady performance. These engines were known for their durability, reliability, and ability to operate for long periods under constant load. Although later replaced by more compact solid injection designs, the Atlas Stockholm Air Blast Diesel represents an important transitional stage in diesel engine development and a significant contribution to industrial power technology in the early mechanical.
So, läuft. Jawohl.
The MWM RH24 stationary engine is a reliable and efficient power unit designed for continuous and heavy-duty operation in industrial and agricultural settings. Manufactured by MWM Motorenwerke Mannheim, a renowned German engine company known for its innovation and durability, the RH24 model represents a strong combination of engineering precision and long-term performance. As a stationary engine, the MWM RH24 is primarily used to drive generators, pumps, compressors, and other fixed machinery. It is built to operate in demanding environments where stable power output and fuel efficiency are essential. The engine's robust design ensures smooth operation, low vibration, and minimal maintenance requirements, making it ideal for both continuous and standby applications. The RH24 is typically a diesel-powered engine, emphasizing high torque at low revolutions, which contributes to its excellent efficiency and reliability. Its cooling and lubrication systems are engineered for consistent performance over extended periods, reducing wear and extending service life. The Schlüter stationary engine, old model, represents an important part of early 20th century agricultural and industrial machinery. Manufactured by Anton Schlüter, a well-known German company based in Munich, these engines were designed for durability, reliability, and continuous operation in stationary settings. Unlike mobile engines used in vehicles, stationary engines powered equipment such as water pumps, grain mills, saws, and generators. Constructed with a heavy cast-iron frame, the Schlüter stationary engine was typically a single-cylinder, four-stroke engine that ran on gasoline or diesel. It featured a large flywheel that ensured smooth operation and consistent power output. These engines were known for their simple mechanical design, which made them easy to maintain and repair, even in rural areas with limited tools or spare parts. Today, old Schlüter stationary engines are prized by collectors and vintage machinery enthusiasts. Restoring and displaying these engines has become a popular hobby, especially in agricultural fairs and technical museums across Europe. Each restored Schlüter engine stands as a testament to early engineering, ingenuity, and the vital role such machines played in mechanizing farms and small industries. Their rhythmic chuff-chuff sound remains a nostalgic reminder of a bygone mechanical age. The Colenberg engine preheat system is designed to ensure reliable engine starting and optimal performance in cold environments. It works by preheating the engine's coolant and, in some configurations, the lubricating oil before startup. This process raises the engine's temperature to an ideal operating range, reducing wear caused by cold starts and minimizing strain on the starter motor and battery. Typically used in marine, industrial, and standby power applications, Colenberg preheat systems employ high-efficiency electric heating elements and circulation pumps to distribute warmth evenly throughout the engine. The result is improved combustion efficiency, reduced emissions, and faster readiness for operation. Built with durability in mind, Colenberg preheaters are engineered for heavy-duty environments, featuring corrosion-resistant components and automatic temperature control for safe and consistent heating. Many systems can be integrated with remote monitoring or automatic start features, allowing users to preheat engines conveniently before use. The Continental IO-520B is a six-cylinder, fuel-injected, air-cooled aircraft engine widely used in general aviation. Part of Continental's iodine monoxide 520 series, it has a displacement of 520 cubic inches, 8.5 liters, and produces around 285 horsepower at 700 RPM. The IO designates This engine is known for its reliability, power-to-weight ratio, and performance at higher altitudes, making it popular in aircraft such as the Beechcraft Bonanza and Cessna 210. The IO-520B features direct drive, wet sump lubrication, and dual magneto ignition for redundancy and safety. Its robust design and strong torque output have made it a preferred choice for both private and commercial piston-powered aircraft operations worldwide. The vintage IH McCormick-Deering 10-20 tractor, produced by International Harvester from 1923 to 1939, was a dependable workhorse of early 20th century agriculture. Its name, 10 to 20 referred to its rated horsepower, 10 horsepower at the drawbar, and 20 at the belt pulley, though many owners found it capable of more. At the heart of the 10 to 20 was a 4-cylinder inline engine with a displacement of about 284 cubic inches, 4.65 liters. It was originally designed to run on kerosene or distillate fuel, with gasoline used only for starting. The engine featured a low compression ratio, allowing it to burn cheaper fuels common on farms of the era. Cooling was achieved through a thermosiphon system and a distinctive cast iron radiator, while ignition was provided by a magneto for reliable, battery-free operation. The engine's slow-turning design, typically running at around 1,000 RPM, delivered strong torque and durability, making it ideal for plowing and belt-driven machinery. Simple construction and easy access to components made maintenance straightforward for farmers. Rugged and reliable, the McCormick-Deering 10 to 20 engine exemplified early international harvester engineering, powering the mechanization of farms across America and earning a lasting reputation for endurance and simplicity. The Holt 75 was a powerful American-built tractor used extensively during World War I. Manufactured around 1918 by the Holt Manufacturing Company of California, it was originally designed for agricultural and industrial purposes but soon found vital military applications. The machine featured a 4-cylinder gasoline engine producing about 75 horsepower, which gave it enough strength to haul heavy artillery, supplies, and equipment across rough, muddy terrain where wheeled vehicles often failed. Its continuous caterpillar tracks, an innovation by Holt, greatly influenced the development of early tanks. During the war, the Holt 75 was used by the US, British, and French armies for towing large guns and other logistics tasks. Known for its durability and reliability, it proved crucial in improving battlefield mobility. The Holt 75's engineering legacy lived on, inspiring later armored vehicle designs and shaping the future of tracked military and construction machinery. Todd Payton's top-fuel dragster engine is a marvel of extreme engineering, built for one purpose: to deliver blistering acceleration and raw power on the drag strip. The heart of the car is a supercharged, nitromethane-fueled V8 engine based on the legendary Chrysler Hemi design. Displacing around 500 cubic inches, 8.2 liters, this powerhouse can generate over 11,000 horsepower and more than 8,000 pound-feet of torque, propelling the dragster from 0 to over 330 miles per hour in less than 4 seconds. Every component of Payton's engine is designed to withstand tremendous stress and heat. The forged aluminum pistons, steel connecting rods, and titanium valves operate at the edge of mechanical limits. A massive Woot-style supercharger forces air into the cylinders, while a nitromethane mixture, which carries its own oxygen, enables explosive combustion. The fuel pump delivers over 90 gallons per minute at full throttle. Each run down the quarter mile subjects the engine to incredible wear, often requiring a full teardown and rebuild. Despite this, Todd Payton and his team at Pettin Racing continue to push the limits of performance and precision, showcasing the ultimate expression of speed, engineering, and controlled chaos in the world of top-fuel drag racing. The Lanz Bulldog 8506, built in 1941, is a classic example of German agricultural engineering during the early 20th century. Manufactured by Heinrich Lanz AG in Mannheim, this tractor was part of the renowned Bulldog series, famous for its rugged simplicity and reliability. The 8506 model featured a single-cylinder, two-stroke hot bulb engine producing around 45 horsepower from a massive 10.3-liter displacement. This slow-revving engine could run on various low-grade fuels, making it ideal for wartime and rural conditions. Its distinctive horizontal cylinder and exposed flywheel gave it a characteristic sound and rhythm, earning the Lanz Bulldog an enduring cult status among collectors and vintage machinery enthusiasts. Built for heavy-duty work, the 8506 was commonly used for plowing, hauling, and threshing. Today, surviving examples of the 1941 Lanz Bulldog 8506 are prized pieces of agricultural history, symbolizing durability, ingenuity, and the golden age of mechanical farming. The 30-60E Rumely OilPull engine was one of the most iconic and powerful tractors of the early 20th century, produced by the Advanced Rumely Company of LaPorte, Indiana. Introduced around 1912, this massive machine represented a significant step forward in agricultural engineering. The 30-60 designation referred to its 30 horsepower at the drawbar and 60 horsepower at the belt, making it suitable for heavy field work like plowing, threshing, and powering large stationary equipment. What made the OilPull unique was its use of kerosene as fuel, thanks to its innovative OilPull cooling and vaporizing system. Instead of water cooling, it used a special oil vapor system to control engine temperature and improve efficiency. The large two-cylinder, horizontally opposed engine ran slowly but generated enormous torque, ideal for the tough prairie soils of North America. Weighing over 20,000 pounds, the 30-60E was not only a symbol of raw power, but also of mechanical reliability. Its rugged design and distinctive rumbling exhaust note made it a legend among early farmers. Today, restored examples are highly prized at vintage tractor shows, representing the dawn of mechanized agriculture and American industrial ingenuity. The 1968 Dodge Charger 572 Hemi is an iconic blend of classic American muscle design and extreme modern power. Originally, the 1968 Charger was known for its aggressive Coke bottle body lines, hidden headlights, and fast back rear, a style that became legendary in car culture. When equipped with a 572 cubic inch, 9.4-liter Hemi V8 engine, this classic transforms into a true street and strip beast. The 572 Hemi, an aftermarket evolution of Chrysler's legendary 426 Hemi, is built for raw performance. Featuring an oversized bore and stroke, forged internals, and high-flow aluminum heads, it can easily produce over 800 horsepower on pump gas, and even more with performance tuning. And the deep, thunderous exhaust note of the 572 Hemi defines its intimidating presence, while massive torque ensures brutal acceleration. Paired with modern suspension and braking upgrades, the 1968 Charger 572 Hemi delivers both vintage style and contemporary performance. It represents the ultimate restaurant, a perfect fusion of old-school muscle and modern engineering. Whether on the drag strip or cruising the boulevard, the 1968 Dodge Charger 572 Hemi stands as one of the most powerful and admired expressions of Mopar heritage. The injected vintage 392 Hemi engine is a legendary powerhouse from the golden era of American muscle. Originally introduced by Chrysler in the late 1950s, the 392 Hemi earned its reputation for unmatched performance and durability. Known as the elephant engine for its massive size and power, it featured hemispherical combustion chambers that delivered superior airflow and efficiency. When equipped with modern fuel injection, the vintage 392 transforms into a perfect blend of old-school muscle and contemporary reliability. The injection system enhances throttle response, fuel economy, and tuning precision while maintaining the engine's raw, thunderous character. Revered by hot rodders and collectors alike, the injected 392 Hemi remains an icon of engineering excellence, symbolizing the timeless spirit of American horsepower and innovation. The Mopar 383 engine is a classic piece of American muscle, known for its strong mid-range torque and reliability. This particular build features a solid lifter camshaft, allowing for higher RPM performance and a more aggressive sound profile. The cylinders have been .060 inches overboard, slightly increasing displacement and improving combustion efficiency. With an 11.5:1 compression ratio, the engine delivers impressive power output, demanding high-octane fuel to perform at its best. This setup represents a meticulous blend of vintage craftsmanship and modern tuning techniques. Every component has been carefully selected and assembled to achieve both strength and precision. The first start of such an engine is always a special moment, the culmination of countless hours of planning, machining, and assembly. Hearing the deep, throaty rumble as it fires up for the first time marks the true beginning of its life on the road or track. Adding to the uniqueness, the engine is mounted on a homemade engine stand, demonstrating the builder's creativity and hands-on skill. This project embodies the spirit of hot rodding, building powerful machines from the ground up, fueled by passion, engineering knowledge, and a love for classic American performance. The Field Marshal Tractor Series 1, introduced in 1947 by the Marshall Sons & Company, Limited of Gainsborough, England, was one of the most iconic single-cylinder tractors of its time. Designed for durability and simplicity, it was powered by a 6.5-liter single-cylinder, two-stroke diesel engine capable of producing around 40 horsepower. This robust machine was renowned for its distinctive pop-pop exhaust sound and the dramatic method of starting using a smoldering paper cartridge inserted into the cylinder and a large hand crank or cartridge start system. The Series 1 was developed in the post-war era when British agriculture demanded reliable, heavy-duty tractors for fieldwork and haulage. Built with a solid cast-iron frame and minimal moving parts, it offered excellent torque and was especially suited for plowing and threshing. Its simple mechanical design made it easy to maintain and repair, even in harsh farm conditions. Distinctive for its rugged appearance and mechanical efficiency, the Field Marshal Series 1 became a symbol of British agricultural engineering. Today, it remains a highly prized vintage tractor among collectors and enthusiasts, representing a bygone era of powerful, no-nonsense farm machinery.
I think it's a lovely tractor. I really do. Now I know it goes. Now I know it's wrong on that. No wrong. I wasn't going to sell you. I wouldn't know. Yeah, but I would add it.
The Continental O-300 engine is a six-cylinder, horizontally opposed air-cooled aircraft engine developed by Continental Motors in the late 1940s. It has a displacement of 300 cubic inches, 4.9 liters, and produces 145 horsepower at 2,700 RPM. Known for its smooth operation and reliability, the O-300 became one of the most popular small aircraft engines of its time. It was widely used in light aircraft, most notably the Cessna 172 during the 1950s and early 1960s. The engine's horizontally opposed configuration provides natural balance and reduced vibration, while its air cooling system simplifies design and maintenance by eliminating the need for a liquid cooling system.
Three blades.
The O-300 evolved from the earlier Continental C-145, sharing many design features but incorporating refinements for better performance and durability. It features a carbureted induction system, wet sump lubrication, and a magneto ignition system. Maintenance is relatively straightforward, contributing to its long service life in general aviation. Even decades after production ceased, many O-300 engines remain in operation, valued for their dependable performance and ease of overhaul. The engine stands as a testament to Continental's engineering legacy and continues to power vintage aircraft around the world. The Continental TSIO-520R is a six-cylinder, fuel-injected, turbocharged, air-cooled aircraft engine widely used in high-performance general aviation aircraft. With a displacement of 520 cubic inches, 8.5 liters, it delivers around 310 horsepower, providing excellent power at higher altitudes due to its turbocharging system. The TSIO designation stands for Turbocharged, Fuel-Injected, Opposed Engine. Renowned for its reliability and smooth operation, the TSIO-520R features efficient fuel management and durable construction. It is commonly found in aircraft such as the Cessna T210 and Beechcraft Bonanza models, offering a balance of power, efficiency, and longevity for demanding flight conditions. The 1883 Crown pumping engine is a remarkable example of late 19th century steam engineering, representing the peak of industrial innovation during the Victorian era. Built in 1883, this engine was designed to pump large volumes of water, typically for municipal waterworks or mines, where reliable and continuous operation was vital. The term Crown refers to both its manufacturer's mark and the robust, elegant design typical of engines from that period. This engine operated on the beam engine principle, using a massive cast iron beam to transfer the motion of a steam-driven piston to a pump rod. Its efficiency and durability made it a key component in public water supply systems before the advent of electric and diesel-powered pumps. The engine's construction featured finely engineered components, including polished brass fittings, ornate detailing, and precision-balanced flywheels, blending functionality with craftsmanship. Today, the 1883 Crown pumping engine stands as a symbol of Britain's industrial heritage. Restored examples are often displayed in museums or heritage pumping stations, where they are occasionally run on steam for public demonstrations. It remains a powerful reminder of the ingenuity and skill that powered the Industrial Revolution and shaped modern engineering. The Deutz MAH RH24 1936 is a classic stationary diesel engine produced by Klockner Humboldt Deutz AG KHD, a pioneering German manufacturer known for its durable industrial engines. This model belongs to the renowned MAH series, which played a vital role in agricultural, industrial, and power generation applications, The MAH 322 is a single-cylinder, four-stroke diesel engine featuring direct fuel injection and water cooling, with a displacement of approximately 3.2 liters. It was engineered for reliability and continuous operation, capable of running machinery such as pumps, generators, and threshers. Built with robust cast iron components, it reflected Deutz's emphasis on longevity and fuel efficiency. The MAH 322's simple yet effective design made maintenance straightforward, contributing to its long service life. Today, surviving examples are prized by collectors and restorers as symbols of early diesel engineering excellence. The Webster inverted stationary engine is a classic example of early engineering innovation used for industrial and agricultural applications. Designed with an inverted cylinder layout, it features the crankshaft positioned above the piston, improving lubrication and ease of maintenance. As a stationary engine, it was mounted on a solid base to power machinery, such as pumps, generators, and workshop tools. Produced by Webster, a company known for reliability and precision, this engine represents the transition from steam to internal combustion technology. Today, restored examples are prized by collectors and enthusiasts for their craftsmanship, mechanical elegance, and historical significance. The Crossley M stationary gas engine is a classic example of early 20th century British engineering, produced by Crossley Brothers Limited of Manchester. Designed primarily for industrial and agricultural applications, the Model M was a single-cylinder, four-stroke gas engine known for its reliability and efficient operation. It typically ran on town gas or producer gas, providing a steady source of mechanical power for workshops, pumps, and small factories before the widespread adoption of electricity. The engine's robust cast iron construction, water-cooled cylinder, and precise governor system ensured smooth and consistent performance. Crossley's engineering innovations, including improved ignition and fuel control, made the M-Series popular both in the United Kingdom and abroad. Today, surviving examples of the Crossley M are prized by collectors and museums as significant pieces of industrial heritage, representing a key step in the evolution of internal combustion technology. ChatGPT Denoy. The YAMZ 238N engine is a robust and reliable V8 diesel engine developed by the Yaroslavl motor plant in Russia. With a displacement of 14.86 liters, it produces around 240 horsepower and 1,200 Newton-meters of torque, providing excellent pulling power for heavy-duty vehicles. Designed primarily for trucks, tractors, and industrial machinery, the YAMZ 238N is known for its durability, simplicity, and ease of maintenance. Its mechanical fuel injection system and sturdy cast iron construction make it highly resistant to harsh operating conditions and low-quality fuel, which are common in off-road or remote environments. The engine's longevity and straightforward design have made it a popular choice across Eastern Europe, Asia, and Africa. Despite being an older design, the YAMZ 238N continues to be valued for its reliability, strong torque characteristics, and affordable spare parts, making it a trusted workhorse in the heavy equipment and transportation industries. The Wikov-Kovarik stationary engine, Bonefeld 2013, represents a classic example of early 20th century mechanical engineering, reflecting both the innovation and craftsmanship of its era. Built by the Czech company Wikov and Kovarik, the engine was designed as a stationary power source intended for continuous operation in workshops, mills, farms, and small factories. Unlike portable or vehicle engines, stationary engines like this one were permanently installed to drive machinery through belts, pulleys, or shafts. The Wikov-Kovarik model is notable for its robust cast-iron construction, simple yet efficient single-cylinder design, and water-cooled system, which allowed it to operate reliably for long hours. Its engineering demonstrates the transition from steam to internal combustion power, marking a crucial step in the mechanization of rural and industrial economies in Central Europe.
Raimund Rolf. Und Steffi.
Bonefeld's 2013 documentation of this engine highlights its historical and educational value, preserving details of its structure, operation, and restoration. Today, the Wikov-Kovarik stationary engine stands as a symbol of early industrial progress, embodying both the ingenuity and durability that characterized European mechanical design in the early 1900s. It remains an important artifact for those studying the evolution of power generation and mechanical technology. The Kelly & Lewis Model MVA stationary engine, produced in 1938, is a fine example of Australian engineering during the interwar period. Rated at 2.5 horsepower, this model reflects the reliability and practicality that made Kelly & Lewis a respected name in industrial and agricultural machinery. Based in Springvale, Victoria, Kelly & Lewis originally manufactured pumps, engines, and other equipment essential to Australia's expanding rural and industrial sectors. The MVA engine was part of the company's medium-duty range, designed for general farm and workshop use. It is a single-cylinder, water-cooled, four-stroke petrol or kerosene engine built with simplicity and ease of maintenance in mind. The engine's heavy cast-iron construction ensured durability and steady operation, while the open crank design made servicing straightforward. The MVA's low-speed operation, typically running around 600 to 800 revolutions per minute, provided smooth, dependable torque for driving machinery, such as shearing plants, chaff cutters, water pumps, and small generators. A distinguishing feature of Kelly & Lewis engines, including the MVA, was their robust governor system and quality machining, which contributed to their reputation for steady running and long service life. Many of these engines were fitted with magneto ignition systems and a simple fuel changeover arrangement for dual fuel operation, starting on petrol and switching to kerosene once warmed up. Today, the Kelly & Lewis MVA is highly regarded among vintage engine collectors and restorers. Its rugged design, Australian heritage, and distinctive rhythmic exhaust note make it a favorite at heritage rallies and machinery shows. Restored examples demonstrate not only early 20th century mechanical craftsmanship, but also the ingenuity of Australian manufacturing during an era when self-sufficiency and reliability were paramount. The 1938 2.5 horsepower MVA remains a proud symbol of Kelly & Lewis's engineering legacy. The MWM RH24 is a robust, stationary diesel engine designed for reliable performance in industrial, agricultural, and power generation applications. Manufactured by Motoren Werk Mannheim, MWM, This engine is renowned for its durability. Is a 4-stroke water-cooled engine with a horizontal design, ensuring smooth operation and long service life even under heavy loads. It typically features direct fuel injection, providing efficient combustion and reduced fuel consumption. Its sturdy construction allows continuous operation for extended periods, making it ideal for driving pumps, generators, compressors, and mills. The engine's simple mechanical design facilitates easy servicing and dependable starting performance. Overall, the MWM RH24 is valued for its rugged reliability, economical operation, and adaptability across a wide range of stationary power needs. The Blackstone portable stationary engine was a renowned example of early British engineering, produced by R. Blackstone and Company, Limited of Stamford, Lincolnshire, England. Founded in the 19th century, Blackstone became famous for manufacturing durable and efficient engines used in agriculture and industry. The portable stationary engine was designed to provide power for various tasks, such as threshing, milling, pumping water, and generating electricity in rural areas before widespread electrification.
Und jetzt bringt durch die Verbrennung die Hitze selber zustande. Hält das Ding jetzt am Glühen.
These engines were typically powered by petrol, paraffin, or diesel, depending on the model and period of manufacture. The portable aspect referred to the fact that the engine was mounted on a wheeled chassis, allowing it to be easily moved from one job site to another by horse or tractor, while stationary described its ability to operate fixed machinery once positioned. Blackstone engines were admired for their robust cast iron construction, reliability, and simple operation, which made them popular with farmers and small industries throughout the early to mid-20th century. Today, surviving examples are prized by collectors and enthusiasts, often restored and displayed at vintage machinery rallies as enduring symbols of Britain's agricultural and industrial heritage. The Gardner GL22 is a classic stationary diesel engine admired for its robust design and reliability. Built by the German manufacturer Gardner, this evaporator-cooled engine was widely used for agricultural and industrial applications, powering equipment such as water pumps, generators, and threshing machines. The GL22 represents mid-20th century engineering excellence, combining durability with mechanical simplicity. At the Newman 2019 Stationary Engine Show in the Netherlands, enthusiasts showcased a beautifully restored Gardner GL22, demonstrating its smooth operation and distinctive exhaust rhythm, a reminder of the craftsmanship and innovation that defined Europe's early diesel-powered machinery. Their Herford Diesel LV22 is a classic stationary diesel engine designed for reliable performance in industrial and agricultural applications. Manufactured by Herford Diesel in Germany, this engine represents the robust engineering typical of mid-20th century European diesel technology. Built primarily for stationary use, the LV22 was commonly employed to power generators, pumps, milling machines, and other machinery requiring a dependable, continuous power source. The LV22 features a single-cylinder, 4-stroke design, optimized for durability and fuel efficiency. Its simple mechanical construction made it easy to maintain and repair, even under harsh working conditions. The engine's heavy cast iron body ensured stability during operation, while its air or water cooling system, depending on the model, prevented overheating during extended use. Perforder diesel engines like the LV22 were renowned for their longevity and low fuel consumption. They were particularly valued in rural and remote areas, where consistent electric power was unavailable and reliability was essential. Today, surviving examples of the LV22 are often restored by collectors and engine enthusiasts, serving as a testament to the craftsmanship and practicality of early stationary diesel engineering. The LV22 stands as a symbol of durable, no-nonsense industrial design from a bygone mechanical era. The Deutz MAH 611 stationary diesel evaporator engine is a robust single-cylinder engine designed for reliable performance in stationary applications such as pumps, generators, and agricultural machinery. Manufactured by Deutz, a pioneer in diesel technology, the MAH 611 features an evaporative cooling system that ensures efficient temperature regulation without the need for a water radiator. Its simple construction, low fuel consumption, and easy maintenance make it ideal for continuous operation in remote or industrial environments. Known for its durability and long service life, the Deutz MAH 611 remains a classic example of early efficient diesel engineering. The Gardner 5 stationary engine is a classic example of early 20th century British engineering, renowned for its reliability and robust design. Built by L. Gardner & Sons Limited of Manchester, this 5-horsepower engine was commonly used in agriculture, workshops, and small industrial operations. It featured a single-cylinder, 4-stroke design with water cooling, offering smooth and efficient power output. Known for its slow-running speed and distinctive rhythmic sound, the Gardner 5 became a trusted workhorse for driving machinery, pumps, and generators. Today, it remains highly prized by vintage engine enthusiasts and collectors for its durability and historical significance. The Primo Swedish hot bulb stationary engine is a classic example of early 20th century engineering used for agricultural and industrial applications. Built in Sweden, this type of engine features a hot bulb ignition system, which preheats a metal chamber to ignite the fuel air mixture. Unlike modern diesel engines, it does not require complex fuel injection or electrical ignition systems, making it robust and reliable in rural conditions. The Primo engine is a stationary crosshead design, meaning it was mounted on a fixed base and included a crosshead mechanism to reduce side forces on the piston rod, extending its durability. These engines were commonly used to power machinery, such as mills, pumps, and generators. Known for their steady rhythm, deep exhaust note, and remarkable endurance, Primo hot bulb engines remain prized by collectors and enthusiasts today as symbols of mechanical simplicity and Swedish industrial craftsmanship.